Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll see elimination of variables during simplification of K-map. We have been given any Boolean function and Boolean expression we represent through the K-map and then we simplify the Boolean function. So during simplification, we need to eliminate certain variables. Then and then we'll be able to simplify our Boolean expression. Let us see how we can eliminate variables. We need to select a group after a representation of minterms in the K-map in appropriate cell. Then the second step, we know that it is a grouping. We have to make a group. In previous lecture, we have seen that the group must be as large as possible. So priority wise, if we see if octet is possible, then first we select octet. If not, then we go for quad. If not, then we go for pair. And if pair is not possible even for certain isolated ones, then we go for single group. So if we select octet, then 3 variables can be eliminated. The reason behind why we select group as large as possible is this. If we select octet, then 3 variables at a time can be eliminated. So simplification is very fast. If we select quad, then 2 variables can be eliminated. In case of pair, 1 variable is eliminated. And in case of single, if we have to select group of single ones, then also we have to do it, but then no variables are eliminated. So this way we can do the grouping and then we can eliminate number of variables to simplify the K-map. Now let us see one example and then we'll see that how variables are eliminated. We have function f of abcd, meaning is we have 4 variables. So we have to prepare a K-map with 16 cell, that is 4 row and 4 columns. It is given summation of m. Summation meaning is the Boolean function is in SOP form, that is sum of product, and m indicates minterms. So minterms are given for which we have high output. So 10, 12, 13 and 14, 4 minterms are given and in equivalent cell we have to put 1. So now as usual we have prepared the K-map with 16 cell. We have AB and CD variables vertically as well as horizontally. Then we write a number. The numbers are very important, 0, 0, 0, 1, 1, 0 and 1, 1. So 1, 0 we take at this stage. That we should always remember. Then for the CD variables also we have 0, 0, 0, 1, 1, 0 and 1, 1. Then we write variables. We know that in SOP form 0 means complemented and 1 means uncomplemented. So we have to write AB. These numbers are for AB. So 1, 1 meaning is both are uncomplemented. So AB. 1, 0 meaning is A is uncomplemented, B is complemented. So this way we can write variables for CD also. Now we have to write ones in the given minterms. So as per the expression we have been given that in 10, 12, 13 and 14 we have to fill 1, but for that we have to write a decimal, equivalent decimal number of all the cells. So we know that how to write these numbers 0 to 15 and then we can write ones in 10, 12, 13 and 14. So 10, 12, 13 and 14 we have written 1 because it is given in the expression. In all other cells we have to write 0. Now if we observe the K-map, we know that octet is not possible because only 4 minterms are there. quad, second option is quad, but we do not have 4 adjacent cells of 1. So quad is also not possible. So we will have to go for pair. We can prepare 2 pairs. One is vertical pair and one is horizontal pair. Now we write product terms. Now this step is very important. We write product term for each cell. Suppose we start with the vertical pair and we write for this cell product term for the 12 number of cell. So what we can write? So we have to take A, B and C, D, because A is your most significant bit and D is the least significant bit. So we have to write in A, B, C, D pattern, and then it depends on which number of the cell we are considering. So for 12 number of cell, we know that it is 1, 1 and 0, 0. 1, 1 for AB and 0, 0 for CD. So if we write a product term for the 12 number of cell, then we can write AB because it is 1, 1 and C bar, D bar because it is 0, 0. So we can write a product term for the 12 number of cell, and that is AB, C bar, D bar. This is very important. Same way we can write a product term for the cell which is adjacent to 12 number, and that is 13 number. So if we write a product term for 13 number, then we can write 1, 1, 0, 1. 1, 1 from the AB, 1, 1 from the AB and 0, 1 from the CD. So it is very simple now that we can write AB, C bar, D, and then we have to add both the product terms because it is sum of product. So we have prepared a pair and then we have written product terms for each cell, and then we have to add for simplification. So that we will do later. Now we write product terms for the second pair, and that is our horizontal pair. So for the 14 number, if we write product term, then we know that AB, that is 1, 1 and CD, that is 1, 0. So we can write AB, C, D bar because here we know that it is 1, 0 for 14 number. So it is C, D bar. And same way, if we write a product term for the 10 number of cell, then we can write for AB it is 1, 0 and for CD that is also 1, 0. So 1, 0, 1, 0, and then it becomes A, B bar, C, D bar because 1, 0, 1, 0. So A, B bar, C, D bar. Then again we have to add both the product term, and then we have to do the simplification. Let us see how simplification can be done. First we write for the vertical pair. So that is AB, C bar, D bar plus AB, C bar, D. From both the product term we can see that we can take a common, and that is AB, C bar. So A, B, C bar we have taken as a common, and D plus D bar. If we do the further process, then we can write as AB, C bar because D plus D bar we know that it is 1. So we can observe that the D variable is eliminated from the Boolean expression for the vertical pair. So we know that when we make a group of pair, we can eliminate one variable. Same way if we write for horizontal pair, then we have to write A, B, C, D bar plus A, B bar, C, D bar. Then we can take A, C, D bar common from both the product term. So B plus B bar into bracket, and then after further simplification it is A, C, D bar because B plus B bar that is equal to 1. So we can see that from the horizontal pair also we have eliminated one variable. So from each group we can eliminate certain number of variables. From pair we can eliminate 1, from the quad we can eliminate 2, from the octet we can eliminate 3, and then we can write our final answer, that is y is equal to, we have to add both the final eliminated product terms, so that is ABC bar plus AC D bar. So we have prepared two groups. From each group we have eliminated one variable, and then we can have a simplified answer. So now again, if we go back to our previous slide, then we can see that how variable is eliminated. So in this slide we can see that if we travel in the adjacent cell in each pair or in quad or octet, we can see that one variable shift from 0 to 1, that is from complemented to uncomplemented, or it can be from 1 to 0, only one variable change when we travel into adjacent cell, right? So here we can see that on the vertical side it is AB and it remains AB, but here we can see that D bar and D, so C bar remain common, but 0 to 1, that is D bar and D, so that variable we have to eliminate. So only one variable is eliminated when we travel from one cell to adjacent cell. Same way, if we see here in the horizontal pair, C D bar remain as it is, but here 1 1 1 0, so B to B bar, so B bar can be eliminated. So this way we have to eliminate, we have to observe and we have to eliminate, because every time we will not go for a simplification of the products. So by observation we can eliminate certain variables. So in next example, function is given, and that is f of ABCD, summation of m, and we have been given certain min terms, so that is 2 3 6 7 8 9 10, and so for the 4 variables we have to prepare Kmap. Then as usual we write variables, that is AB and CD. We write numbers 0 0 0 1 1 0 and 1 1 for AB as well as for CD. We write product terms, that is A bar, B bar and so on. Same way for CD. We give equivalent decimal number to each cell, that is 0 to 15. And then we write 1 in the given min terms. So in 2, 3, 6, 7, 8, 9, 10 and 11 we have written 1. In all other cells we have to write 0. So now if we observe, we can see that octet is not possible. So we will have to go for quad. So we can prepare two quads. One quad at this stage and another quad for this one. Now we have to write a simplified product term for each quad. In case of quad, we know that we can eliminate two variables. So now let us see. If we travel horizontally, then we know that A bar, B bar, A bar, B. So A bar remain common. So we have to write A bar, but B bar to B. So that variable, B variable, we have to eliminate for this quad. And on the CD side, again, we can see that CD and CD bar. The C remain common. We have to write the C. But D variable, that is D to D bar, it is shifting from D to D bar. So that we have to eliminate. So we can write a product term for this quad, and that is A bar C. B and D variable we have eliminated. Same way, if we write a product term for this quad, second quad, when any group cover all the 4 cells, meaning is both the variables are eliminated. So here we can see that vertically it covers entire column. So both the variables C, D must be eliminated, and we have to write a product term, that is AB bar. So for this code we can write a product term, and that is AB bar. So if we write a final answer, then it is Y is equal to A bar C. From the one group we have taken A bar C, and from the another group we have taken A B bar. So A bar C plus A B bar, that is our final simplified answer. So this way we can see that how from the code two variables can be eliminated. We have prepared two code. So from each code we have eliminated two variables, and we have a final simplified answer. Let us see one more example. F of ABCD and summation of M. Numbers minterms are given 1, 3, 5, 7, 9, 11, 13 and 15. So as usual we prepare our K-map. We write variables, numbers, product terms and equivalent decimal number. Now we write 1 in given minterms. So that is 1, 3, 5, 7, 9, 11, 13 and 15. In all other cells we write 0. Now if we observe, we can see that octet is possible. So we go for octet. Now as I said, when any group covers entire 4 cells, then both the variables are eliminated. So if we see from AB side, entire row is taken into group. So A and B, both the variables are eliminated. On the vertical side, it is 0, 1 to 1, 1. So it is shifting from one cell to adjacent cell. So only one variable on the vertical side will be eliminated. So we can see that C bar D and CD. So D remain common. One variable, that is C, we can eliminate, and D, because it remains common, so D we will have to consider for final product term. So from the row side, A and B, both the variables are eliminated. On the column side, we have C variable is eliminated. So if we write a final product term, then we can write that it is equal to D, because A, B and C, 3 variables are eliminated because the group is octet. So final simplified answer we can write Y is equal to D. So when we select octet, we can eliminate 3 variables at a time. That is why if octet is possible, we will always go first for making group of octet. So this way we can eliminate certain variables. Now let us understand the procedure to simplify the SOP form using K-map. Convert Boolean expression in standard SOP. If it is not, we have been given sometime any Boolean expression in normally SOP form, but we will have to check first that whether it is in standard SOP form or not. If it is not, then first we will have to convert it into SOP form. Then prepare K-map and put 1 in the cells as per the given minterms or the truth table. So as per the number of variables, we have to prepare K-map, and then as per the given minterms or truth table, we have to write 1 in each cell. Fill the remaining cell with the 0. In all other cells, we have to write zeros. Check the K-map for the groups. If octet, quad or pair possible, encircle them. Avoid redundant group. After preparing groups, we have to see that if any group is redundant, then we have to avoid this group. Check isolated one. If any one, we know that as per the rule, we have to make a group of all the ones. No one should be left. So check if any isolated one remain. If found, encircle. Add products of all groups and prepare simplified Boolean expression. So at last, after simplification or after elimination of variables as per the group, add product of all groups and prepare simplified Boolean expression. So this will be our answer at last. And if we have been asked to implement the logic circuit, then we have to prepare a logic circuit as per the simplified Boolean expression. Thank you very much for watching my video. Keep watching. Thank you very much.